All right, this video is to show you how to find a missing angle measure in a non-right triangle using the law of sines. In my previous video, I showed you how to find a missing side length or missing length in a non-right triangle using the law of sines. So real quick, we'll just review the law of sines. Remember, in class, we discovered that the sine of angle A, or the sine of an angle divided by the opposite side, which it corresponds to, will be equal to the sine of another angle in a non-right triangle divided by its opposite side, which it corresponds to. So again, we get this equation right here that the sine of A divided by side A is equal to the sine of B divided by side B is equal to the sine of C divided by side C, given this a similar right triangle such as this one here, or non-right triangle, sorry, such as this one here. So now we're going to see, we looked at a couple of examples last time on how to find a missing side length. Now we're going to talk about how I'd go about finding a missing angle measure. So again, I'm still going to recommend that you start out by highlighting the things that are opposite. So if I look at the sine of 77 degrees, I see it's opposite of the side that's labeled 14. And this time, the missing measure is going to be an angle measure. So I'm going to be looking for an angle measure for x, and its side opposite has a length of 9. Now, the way I'm going to set up this equation is going to be almost identical to the way we set it up in the last videos. The only difference is one of my sines is going to have a variable in it instead of an angle. So we're still going to come here, and we're going to select that function tool, and we're going to write sine of 77 degrees. Let's start with what we know is divided by 14. Is going to be equal to, in this case, it's going to be sine of x degrees is divided by 9. And I know I'm going to get my angle in degrees because I've already set Desmos to degrees like I showed in the last video. But I'll go over it again when we get there. I have a proportion, so we're going to go ahead and cross multiply. So we are going to have the 9 times sine of 77 degrees. It's going to be equal to 14 times sine of x. All right. So now, instead of isolating x, I'm going to try and isolate sine of x. But it's being multiplied by 14, so that means I'm going to need to divide both sides by 14. And so what that means we are going to have is we're going to have 9 times sine of 77 degrees divided by 14. It's going to be equal to the sine of x. And as we did in some of our previous lessons, when I'm taking the sine of a variable, the way to get the variable out of the function is to take the inverse trig function of both sides. So that means what I'm going to end up with here is when I write it as x is equal to, what I'm going to have to do for that other side is to take the inverse sine of it. So I'm going to use that inverse trig function. So the inverse sine of 9 times the sine of 77 degrees divided by 14. And so now I'm going to need to put all of this into Desmos to evaluate it. So I come back over to Desmos, and I'm going to have this inverse sine. You can either type it in like you would any statement, or you can go to the onboard calculator or keyboard, and you can, under functions, you can find the inverse sine function. And then we're going to put the rest of it in, 9 times sine of 77, 9 times sine of 77. And then that needs to all be divided by, okay, I want it all divided by, not just part of it. So let me highlight it here. We're going to divide this whole thing. It is equivalent, but I like to put it all in there. And I believe it was 14. Let me double check. Yes, 14. So this goes ahead and tells me that I have 38.78. If I'm going to round to the nearest tenth of a degree, I would allow that 8 to round up the 7 to an 8. So here I would say x is approximately, already forgot, it was 38. There we go, 38.8 degrees. And so we want to make a note that this is in degrees because that's important. In the last video, the two answers were in units because they didn't give us what the units were in the problems. So here is my final answer for this ninth one where I'm finding a missing angle. So x here would be equal to 38.8 degrees. All right. So let's go ahead and take a look here at number 12. Now, the nice thing is usually if they're asking you to find a missing angle, they're not going to give you any missing information like we saw in the second one in the last video, because when they didn't give us the angle we need to use the other two angles to find that angle that I needed. And in this case, since these are non-right triangles, they couldn't not give us one of the sides because I don't have any way to find that missing side. Because as we're learning, the way we do that in a non-right triangle is to use the law of sines. So they're going to give us, when we're finding these missing angles, they're going to have to give us all the information we need. Anyway, let's take a look at number 12. So again, I'm going to use my highlighting technique to identify what is opposite, which helps me set up my law of sines. So the angle labeled x is going to be opposite of the 28, and the angle that's labeled 25 degrees will be opposite of the 12. And so now I can go ahead and write an equation using the law of sines. So I'm going to move my picture over here, maybe. There we go. Maybe it'll be out of the way over there. And so we're going to start. We're going to say the sine of 25 degrees divided by 12 is equal to the sine of x divided by 28. I've got a proportion, so that means I'm going to cross multiply first. That's going to be my first step. So I'll have 28 times the sine of 25 degrees is equal to 12 times the sine of x. Now, again, unlike when I'm finding a missing side length, here I want to isolate the sine of x, not just x yet. So to isolate sine of x, I'm going to divide both sides by 12. So I'll still have 28 divided by 28. I'm sorry, not divided by, times sine of 25 degrees. This is going to be divided by 12. And that's going to be equal to the sine of x degrees. Right? Not just x, but x degrees, or sine of x. All right, so we have that written. Now, again, what I have to do to get x by itself when it's inside of a trig function is I have to use the inverse trig function, because back when you first learned about inverse functions, you should have talked about that the inverse of a function of itself, of the original function, just gives you the independent variable. So what I'm going to do here is I'm going to take the inverse sine of, and inside of that I'll have the 28 times sine of 25 divided by 12 is equal to x. So now this is telling me that this is equal to x. So I have that all of that is equal to x, and we're going to come over to Desmos, and we're going to say, let's see here, we're going to do the inverse sine. So inverse sine of, and then I've got a fraction in here. We're going to go back and double check our numbers. 28 times the sine of 25. So 28 times the sine of 25. And that is divided by 12. So I come back and I'm going to divide this by 12. And it tells me it's 80.43. So if I was going to round this to the nearest tenth, I would use 80.4. So we come back and we're going to record our answer. So we're going to say that x, the function tool, right, if x is approximately, again, I have to say approximately because I rounded, and let's see, x is approximately 80.4 degrees. And this is in degrees because we're finding a missing angle. We want to make note of that. Otherwise, like when we're finding a missing side, it's just in units or whatever units they give us. So our final answer here for number 12 would be 80.4 degrees. That missing angle is approximately 80.4 degrees. And that's it for finding a missing angle measure using the law of sines for a non-right triangle. Until next time, have fun with math.